A pier foundation can meet every visual standard of correctness. It can be perfectly level, precisely aligned, and built with high-strength, reinforced concrete, and still be the direct cause of structural failure in a container home. The failure is not a sudden collapse, it is a slow, invisible twisting force that begins the day the container is set. This happens because of a widespread misconception. A foundation can be strong and still be structurally wrong.
On the surface, the logic of a pier foundation for a container home seems flawless. The supports are placed at the primary load points, the corner castings. They are made of a visibly robust material, concrete, and they can be leveled with a high degree of precision. This method is recommended in countless resources, and it appears to be the definitive professional solution when compared to more basic alternatives. This visual and logical tidiness is deceptive. It relies on the assumption that the ground beneath is a uniform, predictable platform. That assumption is the root of the engineering failure.
The failure of a pier foundation is rarely about sinking. It is about torsion. A shipping container is an intensely rigid, welded steel frame. It is not a flexible system. Think of it like a vehicle's chassis. If you jack up one corner, the entire frame twists. When you place this rigid frame on a series of independent support piers, you are making a commitment that each of those piers will behave identically for the next 50 years. This is a commitment the ground cannot keep. Soil does not behave uniformly, even over short distances. One side of a build site may hold slightly more moisture than the other. One area may have slightly different compaction. This leads to differential movement. One pier may settle 2 millimeters over 5 years, while the one diagonally opposite settles only 1. This millimeter-level difference is all it takes. This tiny, uneven movement between the support points applies a constant, powerful twisting force to the container's rigid frame. This is the next logical fallacy. Faced with this problem, the common response is to over-engineer the individual piers. The thinking is that thicker concrete, deeper footings, or more rebar will solve the issue. This does not solve the twisting problem. The mistake is confusing vertical compressive strength with rotational stability. A stronger pier is better at resisting being crushed. It does not, however, prevent the ground beneath it from moving independently of the other piers. You have simply created a stronger post on an unstable base. The increased strength of one pier does nothing to correct the incompatible movement between all of them. The issue is not the strength of the supports, it is the relationship between them. The correct engineering approach is to stop thinking of the foundation as a series of isolated supports and to start thinking of it as a single, unified system. The primary objective is not to hold weight, but to prevent relative movement between the support points. This is why soil consistency across the entire build site is more critical than the compressive strength of the concrete. The load paths within the container are predictable. They terminate at the corners. The foundation's job is to ensure those termination points remain in a perfect coplanar relationship for the life of the structure. Engineers achieve this by mechanically linking the piers together with reinforced concrete grade beams, or by designing a monolithic slab foundation where the entire system is forced to move as one. In all cases, the goal is the same: to create a foundation that acts as a single, rigid plane, forcing all supports to move in unison, or not at all. Containers don't fail because piers sink. They fail because they twist.